So we're going to do some more with logarithms today, which if you remember, the logarithm is just the power that you raise your base to get what's inside. So log base 1/2 of 8, if you think about it, 2 to the third would be 8, so 1/2 to the negative third would get you 8, which means this logarithm's value is just equal to -3. So a couple new ways of thinking about logarithms and simplifying them. So logarithms and exponential functions are inverses. Like if you think about this one, it's like 3 to what power gets you the inside, which happens to be 3 to the x. So for those two things to be equal, the power that you're raising x to has to be 3. You can also think about the property that they're inverses. So like log base 3 of 3 to the x power, if the base and the exponential function inside it are the same, since logs and exponentials are inverses, those two things are just going to undo each other, and you're just going to get back to the power of x. Kind of like square root of x squared just gets you to x. Same idea. This one is 3 to what power gets you 27 to the x. The bases need to be the same before you can use the property that they're inverses. So let's think about this here. If you rewrite 27, you can make it into 3 to the third, and that way it's base 3. You could also, using your properties of exponents, multiply 3 times x and your exponent together, and then you know that the question mark power has to be 3x. If you think about this one, it's kind of flipped around. We're taking 6 to the power that you need to raise 6 to get x, which is kind of a brain bender, but log base 6 of x is the power we take 6 to get x, and we're taking 6 to that power. That means we're going to get x. Also, you can think inverses, a little bit easier perhaps. You have a base 6 exponential function being raised to a power of a base 6 logarithm, so those two will just undo each other, and you will get what was inside your logarithm, which in this case was x, back. This is just a word problem. So like pH in chemistry is defined by the equation negative log of x, where x is the concentration of your hydronium ions. So if you want the pH of a grapefruit, you plug in your concentration of hydronium ions. We're going to use a calculator because it'll do log base 10 for us and approximate it. So if you type that in, you'll end up with a pH for a grapefruit of approximately 3.2, which makes it acidic if I'm remembering my chemistry and citrus fruits correctly. So just plug it in the formula. Let's do some graphing. So we graphed exponential functions. Easiest way to graph logarithmic functions, fixing my typo, is to graph the exponential function with the same base, and then since they're inverses, swap your x and y coordinates to get the points for the log. So this is log base 2, which means we're going to use an exponential function with base 2 to get our initial points. So if I do 2 to the x here for -1, 0, and 1, I'll get 1/2, 2 to the 0 is 1, and 2 to the first is 1. If I was graphing 2 to the x, I'd be done. We want to graph log base 2 of x. They're inverses. Swap your x and y coordinates, and that'll give you the points on your graph of your logarithm. So if I do that, my new points are 1/2, -1, 1, 0, and 2, 1. Just be kind of careful when you plot them because the x's aren't all whole numbers, so make sure you get them in approximately the right spot. So I'm plotting them here. If you think about your exponential functions, they usually had an asymptote along the x-axis. We've swapped our x and y, so our asymptote for logarithms is going to be along the y-axis. So it'll get close to my y-axis like that. For domain and range, now your domain stops. Like, I never go less than an x value of 0 because I have that vertical asymptote, but my range is -infinity to infinity. Let's do one with a translation. So when you're doing translations, the key is you have to translate the logarithmic points at the end, not the exponential points that you start with. So I'm doing 1/3 for my base of my exponential function to match my logarithm, which gives me the points that I've got there. Then turn it into a logarithm by swapping your x and y values. So my points on log base 1/3 of x are going to be 3, -1, 1, 0, and 1/3 1. Those aren't translated. So I need to translate my points to the left 3 on my logarithmic function, which means take and subtract all of your x values by 3, which will give you some new points. The main thing is you have to subtract them from the logarithmic points. So switch your x and y values before you translate. Do your translations at the end. You're going to end up with these final points that are on the function that you really wanted to graph, your log base 1/3 of x plus 3, which if you plot them is going to look like this. Again, be kind of just careful where you plot things. It's easy to get things backwards. Oh, like I just plotted that in the wrong spot. Let me fix it. Right there. And now since my function was translated left 3, my vertical asymptote is also translated left 3. So now it's the line x equals -3 instead of the y-axis that we're getting close to. So it looks like that. Domain is from -3 to infinity because my x values stay larger than -3.